Miss Kennedy, back at it again. Now we're looking at groups on the periodic table. So you have this nice foldable to fill out going along with groups. So if you flipped it over on the back side, you'll see you got some nice fill in the blanks here. And we can go ahead and walk through that, I suppose. So on the periodic table, groups are what? What do we know? Groups are up and down. Groups are vertical. Groups are columns. Whatever makes sense to you. Oh, that's an ugly P. Sorry, up and down. All right. And then, so that's the first thing to know. Groups are up and down. When we did the reactivity with the alkali metals exploding in the water, we looked only at group 1 and we talked about their reactivity. All right, so next thing, it says on the periodic table, circle the group numbers that have an A in them. This is very, very important. And so if you notice, these are my transition metals. These all have a B. So 3B, 4B, 5B. We're not going to even bother with these. In 8th grade science, we don't do much with these transition metals. We'll deal more with that when you get into high school chemistry. All right, so for now, we're going through. We are circling everything with an A in front of it. So we circled the 1, we circled the 2, we're circling the 3, the 4, the 5. Anybody know why we are circling these numbers? What is the importance? Anyone? What is the importance of these? These tell us the number of valence electrons. I'm going to just put this right here. My circle equals number. I'm going to write out the word number because if I did a number sign, y'all would say it's a hashtag. Number of valence electrons. All right, so those circles indicate the number of valence electrons. So everything in this first group, group 1A, every single element has 1 valence electron. So that means if I was looking at hydrogen and lithium, they have 1 electron on that outer energy level. And remember, that makes them highly, highly reactive because they want to get rid of that electron. They want to bond with another element so that they can get rid of that and be stable. All right, and then it says on the periodic table, color each group a different color. I have no idea how to speed up time on this video, so I'm just going to color real fast. So each group is a different color. You may color this whatever color you want, just as long as each group is a different color. Each group is a different color. I'm going to skip my transition metals because, again, in 8th grade science, we don't care too much about them other than the fact that we know they're metals and we know that they're in their own groups. And again, I don't know how to speed up time to make this thing go faster, so you just get to watch me color while you're coloring yourself. And again, y'all, Miss Kennedy's not a perfectionist, so if my coloring is making you cringe right now, I apologize. But at the same time, I'm not going to try to take my time. All right, so each one's a different color. For the sake of, again, 8th grade science, I'm going to ignore my transition metals just as long as we know each group is a different color because those are all that's their own group. All right, on the back it says the elements in each group have similar, hopefully we remember, that these have similar properties. And this should also say reactivity. I'm going to add that. Reactivity. So similar properties and reactivity. So again, I'm going to go back to the videos where we had the different alkali metals, group 1, reacting with water. They all had some type of reaction, even though our lithium just kind of fizzed a little bit and that was really it. It still reacted with the water. Now, it didn't react like francium might, but it reacted. So they share similar reactivity. Their properties are similar. So for example, group 1, those are alkali metals. Group 2 are alkaline earth metals. We get over to some of the other ones. Those groups are also labeled our noble gases. They're all gases. So similar properties. The atoms in each group have the same number of valence electrons. So again, I wrote that on the front as I circled these. And then group 1A elements have how many valence electrons and share what properties? So my group 1A, again, we circled this on the front. 1A, they have 1 valence electron. And what properties do they share? Group 1, if you remember from the reactivity foldable, they are highly reactive. So they are highly reactive. And again, I said those were called alkali metals. They are highly reactive metals. All right, group 8A, these have, so if I look over to 8A, you should know just by knowing that it's 8A, these have 8 valence electrons. And what properties do they share? Again, think back to reactivity. Reactivity is going to be a big one for us. We put big X's through all of those. I said those are the single ladies. Those are the, or not single ladies, the independent women. Sorry. Those are the ones who don't need anybody else. They've got a full set of valence electrons. They're good. They're not reacting. They're not connecting with other elements. They're on their own. All right, so they share what properties? I'm going to say stable. That's a key word we're going to use, stable. So this is another way of saying not reactive. So stable gases, because those are all gases. If we were to look at them, helium, we think of helium as what you can suck out of a balloon to make your voice go higher, or it's, you know, what makes balloons float because it's less dense than our air. Neon, that's what you see in those neon signs. You think of like Las Vegas and neon lights everywhere. Argon, krypton, xenon, all of these lovely guys here, they're all gases. They're gases. All right, and then 7A. So we know the number in front of the A tells me how many valence electrons. So 7A elements have 7 valence electrons. These are nonmetals. Pull up this again. Remember, the right-hand side of this zigzag are nonmetals. So 7A, we have fluorine, chlorine, bromine, iodine. These are all nonmetals. And these are also very reactive, highly reactive, nonmetals. So these are highly reactive nonmetals. And again, they have 7 valence electrons, and they only need 1 more electron to give them that full set, to be stable, to be happy. So they are trying to rush and hurry and find somebody to meet, find another atom to bond with so that they can get that full set. They just need $1 more to get into that basketball game, and they're going to find someone who can give them that dollar so they can get in there. All right, that concludes our groups. If you wanted to add some more information on here, like if you wanted to say highly reactive, if you wanted to say, like put over here that these are the noble gases, you can do all of this. It doesn't hurt to practice. I'm going to say these are all stable. I'm going to say these are highly reactive. Yeah, it doesn't hurt, guys, to just practice and putting this on there repeatedly. All right, thanks for watching.